4.6% compounded quarterly. This is a no-brainer. Which option should he go with? B, because it's a double benefit. It's a higher percentage, and it's compounded more. They're not asking you which one he should go with, because that would be obvious. They're going to kind of work their way up through the questions they will ask. But the first section, write a function for option A and for option B that will calculate the value after n years. You can't do this problem if you don't have the compound interest formula memorized. Okay? Like I said, I don't make you memorize them for fun. I have those lists of things that you need to memorize because they show up. So that formula is 1 plus r over n to the nt power. So I'm going to do 1 for option A, and option A, the final amount would be the initial amount, 5,000. My rate is 4.5, so 0.045 would be the percentage rate. Over, it's compounded annually, so 1 to the 1t power. Now, they say use n years, so 1n we should be using. And for option B, I'll just use capital B because they don't tell me what to use. Same initial amount of 5,000. My rate is 4.6%, so that's just a subtle change. Compounded quarterly means it's over what, Cameron? 4 to the 4n power. So there's our function. Make sure you use the variables that they describe. Okie doke. The second section says Seth plans to use the money after he graduates from college in 6 years. Determine how much more money option B will earn than option A. So we're just going to use our formulas to calculate the final amount for option A, final amount for option B, and the question is how much more. So we're just going to find the difference. So on part A, I don't know that we necessarily need to show any work. It's just on our calculator. I think to be safe, in case you type something into your calculator wrong, you might want to show who's ever grading your paper that you understand that you're plugging in a 6 for the n. But other than that, it's just type it into your calculator. So 5,000, parentheses 1 plus 0.045 over 1 to the 6th power. So that's $65.11 and 30 cents. Option B, same thing. You could show your work just so in case you type something in on your calculator, the reader knows that at least you get partial credit for knowing to plug in a 6 year. That would be 5,000. 1 plus 0.046 divided by the quarterly 4 raised to the 4 times 6 is 24th power. That's 65.78.87. And then for how much more, we're just finding the difference. So again, you maybe show a subtraction sign so you acknowledge that you know you're taking the difference. Again, in case you mistype in a number and you get the wrong answer, so we can give partial credit, $67.57. And then the third part, and this is a 6-point question, so imagine you don't know that formula. And these parts are real easy. If you don't know that formula, you pretty much forfeit the entire thing, which is horrible. I mean, I think you might need in the past 35 points or something to pass out of the 88 available. So 6 of them could have been real easy, but because you didn't know a formula. Okay. Algebraically determine the nearest tenth of a year how long it would take for option B. So we're going to focus in on option B to double Seth's initial investment. What am I going to do with that option B equation to answer this question, do you think? McKenna? So tell me what to write. I'll see if you know what you're saying but aren't quite saying it clearly or not.
10,000
Okay, so you said what you meant what you said, which is not quite correct, because what would you do for that? Think about what would you do now? You're trying to solve this, but you've got two variables still. Do you know what you might do, McKenna, to fix that? Mason?
Would you set 10,000 equals 5,000?
Right. The initial investment is not changing, McKenna. The initial investment is still 5,000, but we're waiting for that to double, so we're waiting for that final amount to reach 10,000. Good, Mason. So now we can actually solve it because we only have one variable. So divide your 5,000 over. It's going to give you 2 equals. I'm going to figure out what that decimal is. 1 plus 0.046 divided by 4 is 1.0115. This is an exponential equation. The variable is in the exponent. To get it out, I use logs. So log base 1.0115. We'll get rid of that. Divide by 4. N equals. So on your calculator, do you guys remember? I'm going to review it because I feel like one of these, it's going to come up, and I don't know how. But how do you type that? What's the change of base formula? How can I type that into my calculator without searching for the log base? Andrew?
Math.
No, without doing that. Without doing that, the change of base formula. Using just the log button. It's the log of this divided by the log of that. Log of 2 divided by the log of 1.0115. That will get you the same thing that log base number is. And you're supposed to know that, so they may test you on that using variables. They might say, which of the following is equal to this? And have a bunch of options. And the answer would be log of A over the log of B. That's the change of base formula. The log of the second one over the log of the base. So if that happens, I just want to review it. And then, so that's that answer. Divided by 4 gives you 15.15. They say to the nearest tenth of a year, 15.2 years. Okay? Any questions on that? All right. So between the book and the practice exams and the videos online, you're going to pretty much have seen every single question, and we are kind of cruising through the additional 5 questions a little fast. So the only questions that you don't yet have access to that I'm going to show you are these release questions. Some questions that the actual Regents makers came out with before the first exam, so we had an idea of what the questions would look like. So I'm just going to go through these day by day, a couple, whatever we have time for, and then you literally will have seen every single question I have access to. If you choose to obviously watch the review videos that last week or whatever. So take a moment, read this, and I'm going to scroll out, and I want to have you guys take a vote as to what you would pick. I'm going to scroll out just a little bit more so that you can see that that's option 1, 2, 3, 4 is the way it's organized. just going to write this function bigger so that... Okay, on the count of 3, hold up. 1, 2, 3, or 4. Any mark it, set, go. Wow. Uh-oh. Okay. So I thought I did see the most 1s and 3s, I think. And I kind of expected that because of this factor right here. X plus B means you have a root at negative B. And those are the only two that have that. So right away, there's that. Now there's a couple different ways we can now narrow down between 1 and 3. What is the degree of this polynomial in total? 3. We have a quadratic and a linear. So x squared times x is x cubed. It's a negative x cubed, which means it starts high, ends low. If you didn't like that, then you could factor this one into x minus c times x minus c, which is x minus c squared. And if there's a factor of x minus c, there's a root at, oh, they both had that. So that wasn't even helpful. You had to go with end behavior. You had to see that negative coefficient, start high, end low. So that was option 1. Are we on to the second part of August 2016? Yeah. Okay.